Okay, this is that little extra part of 5.5 that I said I was going to make a video over, but that I wasn't going to give you a homework over. It's kind of just like an extra thing, and it's important that you understand like what it means because it could help you in other avenues algebraically, but it's not something I'm going to emphasize right now. So if I asked you to find sine of 2x equals 1, right? Or find the angles for which sine of 2x equals 1 on the interval from 0 to 2 pi. Then there's a couple different ways to do that. You know, you can obviously say when, you know, the function sine of 2x is 2 sine cosine, but as far as solving that, like this one you could actually work it out. Sometimes it's not necessarily possible. So I will go ahead and explore the other option, or the one that you would use 2 sine cosine equals 1. So that's when sine times cosine equals, and then divide 1/2. And then you could think, well, you know, give me the angles for which if I multiply them I get when the sine and the cosine multiply to give me 1/2. And if you think about that, 1 times 0 is 0. Square root of 3 over 2 times 1 over 2 is square root of 3 over 4. Square root of 2 over 2 times square root of 2 over 2 is square root of 4 over 4. The square root of 4 is 2, so that's 2 over 4, that's 1/2, which means that's one of my answers. And then the other option could be 5 pi over 4, because 5 pi over 4, the two negatives would cancel out to give me a positive. And you can also see that when you look at the graph of, well, I don't know if I want to graph that. Yeah, I might as well. Okay. So when you just think about sine of 2x, that's a horizontal compression by a factor of 1/2. Remember, we've got a 2 in the interior, or you can think period equals 2 pi divided by b, which is 2, so the period is pi. So if I were to graph a sine wave with a period of pi, then that would mean this is pi, and this is 2 pi. It would mean this is a 1/2 pi, and this would mean it's a 1/4 pi, right? So 1/4, 2/4, 3/4, 4/4, 5/4. This would be 3/2 pi, and that would be 7 pi over 4. So the question is, when does sine of 2x equal 1? So this is the 1, because it goes up 1 and down 1. And that would be at pi over 4 and at 5 pi over 4. So I already know my answers by thinking about it graphically. I could do this by exploring that. But there's one more way. Sine of 2 theta, or sine of 2x, equals 1. When, okay, instead of thinking of it as sine of 2x, I'm going to think of it as sine of theta equals 1, right? So then the question is, for what angles does sine equal 1? Right? So sine equals 1. Sine's a y value at pi over 2, right? So that's the only time on the unit circle that theta equals, or that sine equals 1, so I'm going to go ahead and say at pi over 2. But theta is 2x. So when 2x equals pi over 2, that means x equals divide by 2, or multiply by 1/2, and you get pi over 4. So you might notice that this only gives me one of my answers, right? So what you have to do is you have to keep adding rotations to the answer that you've got, and then see if you can't come up with the other ones whenever it is compressed, okay? So pi over 2, if I were to add 2 pi to that, because remember the answer is plus 2 pi n, for where n is an integer. So every pi over 2 plus one rotation, or any rotation, any number of rotations, is going to be the same answer. So pi over 2 plus 2 pi. So 2 pi is over 1 times 2, that's 4 pi. So that would mean when theta equals 5 pi over 2 also works. Now, if I let theta be 2x again, and then I solve by multiplying 5 pi over 2. And I multiply by 1/2 on both sides. You see that we again get a quarter angle, and in fact we get 5 pi over 4, which is the other angle that we addressed. Now this method right here doesn't necessarily tell you when to stop. What you have to kind of keep doing is adding another 2 pi. So if we took 5 pi over 2, and we added another 2 pi, because it's just going to keep on going forever and ever. And then I multiply by 2 on top and bottom. That becomes 4 pi. That becomes 9 pi over 2, right? So if I set 2x equal to that, so when theta equals this, theta equals pi over 2 plus any rotation, right? If I add 2 pi again to 5 pi over 2, I get 9 pi over 2. 2x equals 9 pi over 2. We multiply by 1/2. And you get when x equals 9 pi over 4. But x equals 9 pi over 4 is outside of my rotation. So I know that this is my answer, and this is my answer. We do have to be careful though, because it could be more than just one direction that you have to explore. Which just makes it a little bit more interesting when we get into those. Okay. So let me go to another one. What about example 2? Find all the values from 0 to 2 pi such that tangent of 3x equals 1. Okay. So here's what I know. Tangent of theta, forget the 3x for a second, tangent equals 1 when you've got sine divided by cosine and they're the same thing, because then something divided by itself is 1. So that's pi over 4 and 5 pi over 4, and not the other quarters because one of them is negative in that one. So pi over 4 and 5 pi over 4. Or we could just kind of go with pi over 4 and then keep adding rotations, but I think we'll go with both. So tangent of theta equals 1 when theta equals pi over 4 and when theta equals 5 pi over 4. But theta is 3x. So when 3x equals pi over 4 and when 3x equals 5 pi over 4. So as far as answers go, I'm going to multiply both sides by 1/3. And I get the angle pi over 12. So this is a little bit different because that means I wouldn't be able to solve it using the unit circle, because it's not an angle that we have memorized on the unit circle. And then if we multiply by 1/3 here, then we get when x equals 5 pi over 12. Okay. 5 pi over 12 is less than half of a pi, which means we still have some space to grow. So what I'm going to do is I'm going to take my answer pi over 4 and I'm going to add a rotation. Okay? So I'm going to take pi over 4 plus 2 pi, and then I'm going to take 5 pi over 4 and add 2 pi. And just remember that 2 pi is 8 pi over 4. Okay, so this is 9 pi over 4. And that's when theta equals 9 pi over 4. This is still true. Tangent will equal 1 at 9 pi over 4. But that our theta is in fact 3x. And if I solve that equation and I multiply both sides by 1/3, then I get 9 pi over 12, and 9 pi over 12 simplifies to 3 pi over 4. That's still in the first quadrant, which means that's also an answer. So far I've got pi over 12 and 5 pi over 12. I've got 3 pi over 4. Let's talk about this one. 5 pi over 4 plus 8 pi over 4 is 13 pi over 4. 3x equals 13 pi over 4. Multiply by 1/3. And I get 13 pi over 12, which is just over 1 pi, which means it's still in the interval from 0 to 2 pi. So to be clear, just a reminder, we're not done. Tangent of 3x equals 1 when 3x equals any angle such that tangent of that angle equals 1. So if tangent of pi over 4 equals 1. Then that means when 3x equals pi over 4 and x equals this, then tangent of that will equal 1. Tangent of 3 times that will equal 1. And again, if you think about that, plug in pi over 12 right here. 3 times pi over 12 is pi over 4, and tangent of pi over 4 is 1. Plug in 3 pi over 4. Well, that one's not as easy to see because you don't know 9 pi over 4. But for this one over here, you do. If you were to plug in 5 pi over 5 pi over 12 into this right here, then you would get 15 pi over 12, and 15 pi over 12 simplifies to an angle you know. 5 pi over 3. No, 5 pi over 4. 15 twelfths, yes. Okay. And so then tangent of 5 pi over 4 is 1. Okay. But like I said, this is just over one rotation, or 1 pi, not even a full rotation. So we're going to keep on going. We're going to take 9 pi over 4, because last time we took pi over 4, and then we added 2 pi. Now we're going to take 9 pi over 4, and we're going to add 2 pi again. Because remember, it's all the angles when theta equals pi over 4. When theta equals pi over 4, tangent of that angle. Tangent of 9 pi over 4. So basically what I've done is I've said, okay, pi over 4 plus a full rotation. Now this is 9 pi over 4 plus another rotation. Now it's 17 pi over 4. Because if you add 8 pi over 4 to 9 pi over 4, you get 17 pi over 4. So now I'm solving when 3x equals 17 pi over 4. Multiply both sides by 1/3. And I get when x equals 17 pi over 12. Now that's getting close to 2 pi. So we might be reaching our limit. We're going to add to 13 pi over 4 another rotation. So 13 pi over 4 plus 2 pi, which is 8 pi over 4. 13 plus 8 is 21. So that's 21 pi over 4. When 3x equals 21 pi over 4, multiply by 1/3. Then you get when x equals, and 21 divided by 3 is 7, so 7 pi over 4. We have reached 7 pi over 4. I'm pretty sure that if we added another rotation, then it would be outside. Now notice how this said tangent of 3x, and we ended up with 6 answers, right? We started out with 2 answers, and then because it was compressed by a factor of 1/3, now there were 3 answers per, or 2 more after giving that first one. So when you compress it, tangent will equal 1 3 times as many times, if that makes sense. If you think about the graph, tangent equals 1. This is pi over 2. This is 3 pi over 2. This is pi. This is 0. So when you compress it by a third, we have it at pi over 4. It equals 1 normally. Yeah? Over half and then up 1. But then now you compress that by a third. And so the waves are much thinner. And so it would be, instead of a third of where it normally hits 1, which is pi over 4, it's now pi over 12. But then that means you're going to have a lot more waves between here and there, right? Or between 0 and 2 pi anyway. So, there you go. Alright. Let's talk about this one. This one's a little bit more interesting because it goes in the opposite direction of what we've just been doing. So, example 3. Find the values between 0 and 2 pi such that sine of x divided by 2 equals the square root of 3 over 2. So we're going to set about solving when sine of theta equals the square root of 3 over 2. And that's when theta equals, sine is the y value, sine is square root of 3 over 2 at pi over 3 and at 2 pi over 3. That's where it's the positives. Square root of 3 over 2. The one I drew is clear. At have pi over 3 sine the square root of 3 over 2, and a 2 pi over 3 sine the square root of 3 over 2. So when theta equals pi over 3, and when theta equals 2 pi over 3. Alright, but what we need to do is instead of theta, we need to remember that it's actually x divided by 2. So when x divided by 2 equals pi over 3, because theta is x divided by 2. We're going to multiply both sides by 2, and we see one of our answers is 2 pi over 3. Okay, cool. Then I'm going to set x over 2 equal to 2 pi over 3. I'm going to multiply both sides by 2. And I see when x equals 4 pi over 3. So 4 pi over 3 is already right here. We went from pi over 3 to 2 pi over 3, and then 2 pi over 3 to 4 pi over 3. So you could see about adding another rotation. So I'm going to take the first one and add a rotation. Pi over 3 plus 2 pi. 2 pi is how many thirds? It is 6 thirds. So that's when theta equals 7 pi over 3. I don't think this is going to work, because if I set x over 2 equal to 7 pi over 3, I mean, that's already outside of the interval anyway, 7 thirds. And so now it's 14 thirds, so that's outside of the window, because we're only looking for answers from 0 to 2 pi. Which means we have two answers, 2 thirds pi and 4 thirds pi. Okay, so this is a horizontal stretch by a factor of 2, but we still have only our 2 answers. Okay, they're just further out. Alright, let's look at this one. Find all the values of x on the interval from 0 to 2 pi such that cosine, so let's do another horizontal stretch. Cosine of x divided by 3 equals 1/2. So cosine of theta equals 1/2 when theta equals, so cosine is 1/2 at theta equals pi over 3. That's negative 1/2, that's negative 1/2, and then there's positive 1/2 at 5 pi over 3. Right? So cosine of theta equals 1/2 when theta equals pi over 3 and 5 pi over 3. But we're not dealing with theta, we're dealing with x divided by 3. So when x divided by 3 equals pi over 3, or when x, I don't know why I can't write, when x divided by 3 equals 5 pi over 3. So I'm going to multiply both sides by 3, and that equals pi. So one of my answers is when x equals pi. And that makes sense, because if I plug in pi, I get cosine of pi over 3, and that is 1/2. Here, if I multiply by 3, I get x equals 5 pi. While that is an answer, it is not an answer between 0 and 2 pi. So this horizontal stretch by a factor of 3 made it to where this one answer is no longer, this answer is no longer an answer on the interval. So the only answer we have is 0 to pi. So just as a reminder, just so we can kind of play with that, here is cosine with an interval from 0 to 2 pi. If I stretch that by a factor of 3, I'm going to pretend, let that be 6 pi. Then my new wave, and just so you can see, reminder, we're equaling 1/2 here and here. That's pi, that's half pi, and that right there is pi over 3. And that right there is 5 pi over 3. Okay, but anyway, so those are my normal answers. But now we're stretched out to a period of 6 pi, right? So if you have a period of 6 pi, that means the cosine wave starts here, ends there. Halfway at 3 pi, we should be at the minimum. And then at 3 pi over 2, which is right here, 1.5 pi, it should be at the 0. And then it should be at the 0 at 3, 4, 5, 6, so it should be right here at 9 pi over 2, right? the question of when does it equal 1/2? Well, it equals 1/2 here at pi, and here at 5 pi. But 5 pi is outside my window because I only want to find answers from 0 to 2 pi, so my answer is just pi now. Okay? It's the original answers multiplied by 3. I hope that makes sense a little bit. I'm going to do one more that's a little bit interesting, and then I'm going to call it good. So, example 5. Find all the answers from 0 to 2 pi such that sine of 2x minus pi over 3 equals 1/2. So this one's kind of interesting because we're trying to find all the angles for which 2 times the angle minus a third of pi, and you take the sine of it, you get 1/2. So again, we're going to let this be sine of just theta. And we're going to talk about the values of theta that equal sine equals 1/2. So sine is the y value, and sine equals a positive 1/2 at pi over 6. And at 5 pi over 6, those are the 2 times it's positive. So on the unit circle, when theta equals pi over 6, and when theta equals 5 pi over 6. But theta is not what we're interested in, but just so we can keep it going. This is a horizontal compression by a factor of 1/2, which leads me to believe that there's going to be twice as many answers as usual. So what I'm going to do is I'm going to go ahead and add a rotation, but I'm going to add it twice, just to show you that we will only be within, we'll only get 2 more answers after these. Okay, so if I add a rotation here, then 2 pi is 12 pi over 6, so that's 13 pi over 6. So I just added 2 pi. Okay, adding 12 pi over 6 gives me 17 pi over 6. Okay, I'm going to add 2 pi again. Adding 12 pi over 6 gives me 25 pi over 6. And I'm going to leave it at that, and then if that one works, then we'll keep going. But theta is not that. Theta is 2x minus pi over 3. So we're going to solve. I'm going to add pi over 3. So pi over 6 plus pi over 3. And that gets rid of that. And then I'm going to multiply by 1/2, and that gets rid of the multiplying by 2. So 1/6 plus 1/3, we're going to multiply top and bottom by 2 so that they have a common denominator. 1/6 plus 2/6 is 3/6, and 3/6 is 1/2. So it's 1/2, half of pi, and that is, let me make sure, 3 pi over 6, yeah. So pi over 4. This one is not as easily done just by graphing because it's a horizontal compression and a horizontal stretch. So it's a horizontal compression by a factor of 1/2, and then a stretch to the, or not stretch, that is compression and then a shift, a horizontal shift to the right pi over 6. Remember, you're going to factor out that 2. Okay, so I'm going to set 2x minus pi over 3 equal to 5 pi over 6 now. So we would add pi over 3, and then we'd multiply by 1/2. So once you start realizing that's a pattern, you could just keep on saying, well, these are all 6, so this is going to be 2 pi over 6. So that's 7 pi over 6 times 1/2, so that's 7 pi over 12. So when x equals 7 pi over 12, and I'm going to do some shortcuts. 2x minus pi over 3 equals 13 pi over 6. If we take 13 pi over 6, we add 2 pi over 6, which is 1/3, and we multiply by 1/2. So that's 15 pi over 6, so 15 pi over 12. Now the reason why I haven't stopped yet is because we're still within one rotation, or one full rotation, 2 pi. 15/12 is just over pi. Okay. 2x minus pi over 3 equals 17 pi over 6. would, again, add pi over 3, or 2 pi over 6, and then multiply by 1/2. 17 plus 2 is 19, so that's 19 pi over 6 times 1/2, 19 pi over 12. 19 pi over 12 is getting close to 2 pi, but it's not quite. 2 pi is 24 pi over 12. But this one right here, if I take 25 pi over 6, and I add 2 pi over 6, and I multiply by 1/2, then I get 27 pi over 12, and that is greater than 2 pi. So that's out. So we would have 4 answers. Pi over 4, 7 pi over 12, 15 pi over 12, and 19 pi over 12. And 15 pi over 12, you could obviously simplify down to 5. 5/4? 5. And then you can kind of see, you got the 7/12 and the 17/12, which is just pi away. And you got pi over 4 and 5 pi over 4, which is just pi away. Because pi plus 4 pi over 4, which is pi, is 5 pi over 4. And there you go. That's because it was a horizontal compression by a factor of 1/2. So that's kind of the extra stuff. Like I said, I'm not going to focus on that. I'm not going to put something like that on the test unless I expected, like, on that first one. Well, let's see. Yeah. If you got a problem like that, it would have to be something where you could use the half angle identity and set that equal to it. So you'd square and then multiply by 2 and then subtract the 1 and divide by a negative. Or double angle, in which case you could just replace it with one of those. But there you go. Hope you find it interesting.